This is video 17.2. We will be solving a problem involving the electric field. The question: charges 1 and 2 are arranged as shown in the figure below. We'd like to know, what is the magnitude and direction of the electric field at point A? Give the direction with respect to the x-axis. Step 1 is to find the electric field due to charge 1. The electric field is given by the following formula. Here, R1 is the vector which connects the location of charge 1 to the point A. We find its coordinates by taking the coordinates of the point A and subtracting the location of charge 1. In this case, it's simply 2, 2. And the length of this vector is equal to the square root of 8. Now we can plug this into the above formula and substitute the value of K, which is Coulomb's constant, and has the value 9 times 10 to the 9 in units of kilogram meters and seconds. Simplifying this, in coordinates we have 63.6, 63.6 volts per meter. Volts per meter is one of the units for electric field. Now we repeat the same process for charge 2. We have the same formula, and in this case, R2 is the vector which connects the location of charge 2 to the point A. So we take the coordinates of A and we subtract the coordinates of charge 2. We have negative 4.5, 2, which has a length approximately equal to 4.92. We substitute the values into the formula above, and we get the following value for the electric field in coordinates. Step 3 is to find the total electric field. Now that we know the electric field due to charge 1 and charge 2 at point A, we can add them to find the total electric field using the principle of superposition. Now, because the electric field is a vector, we add vectors by adding their components. When we do this, we get the following value for the electric field. Now, in the problem, it was asked to give the electric field in terms of a magnitude and a direction. This is another equivalent way of specifying a vector. The electric field is drawn below, including the x and the y components, the total electric field, and the angle theta with respect to the x-axis. We find the magnitude of the total electric field in the same way that we find the length of any other vector. We square the components, add them, and take the square root. This gives us a value of 100 volts per meter. Now to find the angle. Because the tangent of theta is equal to the opposite over adjacent, one can see that theta is equal to the arctangent of the ratio of the y component to the x component. When we plug in the values found above, we get a value of 33 degrees. And this concludes video 17.2. Check out Physics X on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.